The gut microbiome is no longer just a fringe curiosity for yogurt commercials and kombucha enthusiasts. It's now firmly at the center of some of the most cutting-edge metabolic research. And one area where the spotlight is getting brighter? Insulin resistance. That sluggish, often silent metabolic state where the body stops responding properly to insulin is a key step toward type 2 diabetes, and growing evidence suggests the gut microbiome plays a much bigger role than anyone realized. Recent clinical trials are starting to connect the dots between the foods we eat, the compounds our gut bacteria produce, and how well or poorly our cells respond to insulin. It turns out your gut isn't just adjusting your lunch, it's helping regulate your blood sugar. Let's start with a fundamental concept. The gut bacteria ferment dietary fiber and resistant starches into short-chain fatty acids, SCFAs, compounds like butyrate, propionate, and acetate. These SCFAs don't just stay in the gut. They get absorbed and signal throughout the body, including in the liver, pancreas, and fat tissue, where they help fine-tune glucose and fat metabolism. One of the most impressive SCFAs is butyrate. It's not just fuel for colon cells. It also acts as an anti-inflammatory agent and epigenetic modulator, helping suppress the chronic inflammation that drives insulin resistance. In clinical studies, individuals who consumed more fiber-rich foods, like legumes, whole grains, and nuts, showed increased butyrate-producing bacteria, which was associated with improved insulin sensitivity, even without weight loss. That's a big deal. It means food quality, not just calorie count, matters. Meanwhile, another group of gut-derived compounds is under scrutiny: lipopolysaccharides, LPS. These molecules, found on the outer membrane of certain bacteria, can leak into the bloodstream when the gut barrier is compromised. Think ultra-processed diets, high saturated fat intake, low fiber. Once in circulation, LPS triggers a low-grade inflammatory response, one that directly interferes with insulin signaling. This phenomenon, called metabolic endotoxemia, is now thought to be a root cause of insulin resistance. Clinical trials have shown that diets rich in saturated fats and low in fiber increase LPS levels, while higher fiber, plant-forward diets help reinforce the gut lining, reduce LPS leakage, and tamp down inflammatory cytokines like TNF-A and IL-6, both implicated in impaired glucose regulation. Then there's bile acid metabolism, another microbial theater of insulin resistance. Certain gut microbes can convert bile acids into secondary bile acids, which interact with receptors like FXR and TGR5, major players in glucose and lipid metabolism. Diets rich in whole plant foods seem to encourage healthier bile acid signaling, while high-fat Western diets push things toward imbalance. One trial, for example, put pre-diabetic individuals on a high-fiber, microbiome-targeted diet and observed not just shifts in gut composition, but significant improvements in postprandial glucose, insulin sensitivity, and even GLP-1 secretion, a hormone that enhances insulin response. The change wasn't just from losing weight. It came from microbial shifts and their downstream effects on host metabolism. To make it even more interesting, personalized trials have shown that individuals respond differently to the same foods, depending on their gut composition. One person might see a blood sugar spike from white bread, while another doesn't, and the difference can come down to the types of bacteria colonizing their gut. So, what's the bottom line from these trials? Insulin resistance isn't just about sugar or carbs. It's about how your body handles those nutrients, and your microbiome is a big part of that equation. Foods that feed beneficial gut bacteria, think pistachios, lentils, oats, green bananas, artichokes, don't just make your digestion smoother. They may directly influence how your cells respond to insulin, how much inflammation you're carrying, and how resilient your metabolism is under stress. This is Metabolic Health 2.0. It's not just calories in, calories out, it's molecules in, microbes out, and hormones somewhere in between. Your microbiome is always watching what you eat, and increasingly so are the scientists.